Hello guys, and welcome to today's video on partial derivatives. So in today's video we're going to be looking at the product rule of partial derivatives. In the first video we talked about the introduction of partial derivatives and we did partial derivatives from first principle. So I'm going to be posting the link of that video in the description of this video so you can watch for proper understanding. But in today's video we are going to be looking at product rule of partial derivatives. Now what is the product rule? Let's say Z is a product of U times V, where U itself is a function of both X and Y, and V also is a function of X and Y. Now, since these two functions or these two variables are multiplying one another, it means to differentiate this function Z, I have to do that using the product rule. And what is the product rule? Let's say I want to differentiate Z with respect to X. By product rule, you keep the first variable constant, so you hold U as a constant, differentiate V partially with respect to only X, since I am to differentiate Z with respect to X, plus, now you keep the second variable constant, hold V as a constant, now differentiate U also partially with respect to only X. So this is simply the idea behind the product rule. Now at the end of every example solved, I'm going to be using a shortcut to explain each of the examples we are going to be solving. Okay, now let's pick a very simple example to explain this concept. Okay, let's say Z is equal to x squared y squared, and you're asked to find the partial derivative of Z with respect to only X. Now since I have Z to be multiplying since I have Z to be equal to x squared multiplying y squared, it means I am going to be employing the product rule of partial derivatives to differentiate Z only with respect to X. First thing to do is let U be equal to what? X squared. And secondly, let V to be equal to Y squared. Now, if I do this, I have assigned I have assigned X squared to be U, and I have assigned Y squared to be what? V. This simply means that Z is now what? Z is now, in place of x squared is U, so I have U times, in place of y squared is V, so Z is now the product of U and V, which means I am going to be employing the product rule to solving this problem. Now, if you look at the given function from U equal to x squared, this means that U is a function of only X, which means U depend on the value of only X to be defined. And if U is a function of only S, this simply means I can only differentiate U partially with respect to X. So therefore, partial derivative of U with respect to X is now equal to, remember the principle of differentiation, use the power to multiply the variable, then subtract 1 from the power. And that simply gives us what? 2, which is the power, multiplied by the variable x to the power of 2, then subtract 1 from the power. This simply implies that partial U all over partial x simply gives us what? 2 times x. So the partial derivative of U with respect to x is actually 2x. Now keeping this aside, again from V equals y squared, this simply implies that V is now a function of only y, because V depends on only y to be defined. And as such, this actually means I can only differentiate V with respect to y and not with respect to x. But since I am asked to differentiate this function Z equals x squared y squared, since I am asked to differentiate this function Z equals x squared y squared with respect to x, it means that from the law of product rule, let me pull it back a bit. From the product rule, we simply said derivative of Z with respect to x alone simply means I have to differentiate V with respect to x. I also have to differentiate U with respect to x. If I am to differentiate Z with respect to x, then plug it back into what? This equation, which is the product rule of partial derivatives. All right. Now going back to this, since V is equal to y squared, it means V is a function of only y, and therefore I can only differentiate V with respect to y. since I can only differentiate v with respect to y, this simply means that the partial derivative of v with respect to x automatically becomes what? 0. Because now I am going to be seeing y as a constant, and the derivative of every constant is simply 0. Hence, the partial derivative of v with respect to x becomes 0. Now, having found partial v partial x to be 0, and I found partial u all over partial x to be equal to 2x, then I can employ the product rule of differentiation. Remember, product rule of partial derivative once more, if I have z to be a product of two functions u dot v, we simply say that partial z all over partial x is equal to, remember, keep u as a constant, so hold u, differentiate v partially with respect to only x, plus again, now you keep v as a constant, so hold v, now you differentiate u partially with respect to only x. Now, by so doing, we have found partial v partial x, that's 0. We have found partial u partial x, which is 2x. We can now plug in all the values into what? The formula. Not forgetting we said let u be equal to x squared, and we said let v be equal to y squared. So let's plug in these values into this equation for the partial derivative of z with respect to x. Okay. So the partial derivative of z with respect to x is now equal to, remember, hold u, and u is what? X squared. So hold x squared, differentiate v with respect to x. Partial derivative of v with respect to x gave us 0. So that means x squared times 0 plus, now you hold v as a constant. And what is v? Once more, we say let v be equal to y squared. So hold y squared as a constant, differentiate u with respect to x. The partial derivative of u with respect to x gave us over here as 2x. So you simply have times 2s. So this is equal to, of course, x squared times 0 remains 0 plus 2x times y. Y squared gives us 2xy squared. So this simply implies that the partial derivatives, okay, the partial derivatives of z with respect to x only is equal to 2xy squared, and that's the answer to that given question. So as always said, at the end of every example solved, we are going to be explaining with a shortcut. So I'm going to be showing you the shortcut on how to differentiate this function without going through the product rule method. Okay, so the shortcut helps you to know it before applying the product rule, so you can cross check your answer after applying the rule. All right. So in the question, we were given that z is equal to x squared y squared, and we are asked to find the partial derivative of z only with respect to x. Now here is the product rule by shortcut. Partial z all over partial x is now equal to, since the two of them are multiplying, all I will do is this: hold y squared as a constant, because y is not changing, z is changing only with respect to x. So you simply hold y as a constant. If you hold y as a constant, let's differentiate only x squared. If I differentiate only x squared, remember the theorem, use the power 2 to multiply x squared, then subtract 1 from the power, so you have minus 1. So this is actually y squared into, this gives you 2x to the power. Here we have 2 minus 1, which is what? 1. And it's as simple as this. The partial derivative of z with respect to x is given as what? 2xy squared, which is the same answer as what we obtained when we employed the product rule. Alright guys, so we are going to move to the next example now. Alright, so before going into the next example, take a moment please to like the video and subscribe if you're new to the channel. Okay, so let's move to the next example. Welcome back guys. So let's say we are given f of xy equals x squared plus y, and we are asked to find f of x. Now when they say find f of x, this simply means find the partial derivative of that function with respect to only x. That's what it means. Alright, now again, I am experiencing the product of two functions, x squared multiplying cos y. So these two functions are multiplying one another. So to do this, remember, first thing to do is let u be equal to the first variable x squared and v to be equal to the other variable cos y. If I have this, this simply now implies that f of x y is now equal to, in place of x squared, we call that u. So I have u times, in place of cos y, we call that v. So it becomes u times v. So which means I'm going to be employing the product to differentiate this function. And from product rule, the partial derivative of f with respect to only x becomes, remember the theorem, hold u as a constant. So keep u, differentiate v partially with respect to what, x, plus now you keep v as a constant, differentiate u partially with respect to what, x. This is the product rule. So all our target now is to differentiate v with respect to x, differentiate u with respect to x. That's all we are doing. Now from u equals x squared, once again, since u is equal to a term of x, this simply means that u is a function of x, because u depends on the value of x to be defined. And if u is a function of x, it simply means I can actually find what, the partial derivative of only u with respect to x. And if I differentiate u partially with respect to x, I will simply have what, 2 times x, because this is x to the power of 2. So use the power to multiply x. So that gives me what, 2x. Again, I have v to be equal to what? V was given as cos y, which means v depends on the value of y. If I say y is 30 degrees, it means v becomes cos 30. So v has a value. So this actually implies that v is a function of only y. As such, I can only differentiate v with respect to y and not with respect to x. So that simply means differentiating v with respect to x in this case becomes 0, because x is now because this variable or this function v does not contain x. So it means y in this case automatically becomes what, a constant. Therefore, the partial derivative of v with respect to x automatically becomes what, 0. Now, if I know these partial derivatives, I can now simply what, plug them into what, this equation to find the value of the partial derivative of the function with respect to x. All right, so let's do it. So now, so keep in mind, partial x is u. So let's plug back everything into the equation. The partial derivative of that function with respect to x is now equal to, so the formula says keep u as a constant. And what is u? U is equal to x squared. So keep x squared as a constant, differentiate v partially with respect to x. Partial v partial x give us 0. So we have times 0 plus, now you keep v as a constant, and v is simply what, cos y. Then differentiate u partially with respect to x. Partial derivative of u with respect to x give us 2x, so you have times 2x, and this is equal to x squared times 0 is 0, plus 2x times cos y gives us 2x cos y. So this simply implies that partial f all over partial x, which is same thing as fx, is simply equal to 2x cos y, and that is the answer. Now let me show you guys the shortcut approach to this, just like we did in the first example. Now we have f of xy to be equal to x squared cos y. Okay, so we're going to be using the product rule, or the shortcut to the product rule. I want to find f of x, which means differentiating this function only with respect to x. Since this is cos y, it means y is a constant. Simply hold cos y as a constant. Differentiate only the variable with x. So I have x squared here. Differentiating x squared, I simply have what? 2 times x. And this simply implies that fx is equal to what? 2x cos y, which is the same result as what we obtain when we use the product rule approach. All right, guys, so that's it for this video. In the next video, we are going to be solving more problems on product rule of partial derivative. Thank you, guys. I will see you in the next video. Cheers.